Good afternoon. I am MaoshengHe from Leibniz Institute for Atmospheric Physics. I'm very glad to be here to talk about wave-wave interactions in the mesosphere and low atmosphere region. This map displays examples of multi-station configurations we have used for diagnosing horizontal wave scales in the MMT region. Let me show you an example using observations from these two stations during the Southern Hemispheric Southern Stratospheric warming 2019. The first panel is the wavelet of the zonal winds at 95 km altitude over one station, and the second panel is the wavelet for the other station. The third one is their cross product. The color hue of the cross wavelet denotes the phase difference in between the stations, which is a function of the zonal wave number. In all these three panels, there are two peaks nearby the periods of 6 and 10 days, respectively, and the color of the cross wavelet suggests both peaks are associated with zonal wave number 1, which further suggests they are Rossby wave normal modes or planetary wave normal modes. And an 8-year average, 8-year version of this cross wavelet for the same season suggests that the 6-day wave is a seasonal behavior, whereas the 10-day wave is associated with the SSW. This association is not surprising because it is often observed in the northern hemispheric SSW, for example, for 2009 and 2010 at this latitude. Come back to the SSW 2019. We also calculated the cross wavelet in the period range nearby 12 hour, and in this spectrum, the most dominant peak is the 12-hour associated with wave number 2, and the 12.4 hour associated also with wave number 2. They can be explained as the migrating solar and lunar tide. And in addition, there's a zonal wave number 1 and zonal wave number 3 peak. They can be explained as the secondary wave of nonlinear interaction between this 10-day wave and the migrating solar tide. We refer these two peaks as LSB and USB, the upper and low sideband. At 12 hours, the peak is cloudy. Therefore, we calculate the cross spectrum at the altitude. In compared to other year, there's a gap, there's a depletion. We note that the 10-day wave and the LSB burst at the same time, whereas the USB burst after the weakening of the 10-day wave, as sketched in this plot. The timings can be explained in terms of the monlinear relation. In generation the low sidebands, energy flows from the tide to both the planetary wave and the low sidebands, and the planetary wave is amplified, even though it is a parent wave. This situation is same to the generation of laser. In the laser generation, the photon is a parent wave, but it is also amplified. Similarly, we name this kind of planetary wave amplification as pulse tide, planetary wave amplification by stimulated tidal decay. Actually, laser is not only an analogy, it is the nonlinear interaction between W waves. Photon absorption and emission are the up and low sideband generations, and monlinear relations are known as Planck relations in quantum mechanics. The resonant condition equals to conservations of energy and momentum. Here is the second example of the implementation of the resonant condition. In this implementation, we use the Lambert-Scargo cross spectrum for identifying the zonal wave number, as detailed, for example, in this paper. In this work, we first find the full migrating tidal component during the summer of 2019. And if all of these tides interact with the same planetary wave, let's say the blue one, then where could we expect the secondary wave of these interactions in this spectrum? According to the resonant condition, these secondary waves will located at this blue frequency. But then experimentally, how can we identify these potential peaks? To do this, we designed a method called the spectral periodical table, inspired by the periodical table of element. We first cut the original cross spectrum into 0.5 cycle per day weight slots. Then we wrap these slots along this magenta line. In the end, constrained by the regional condition, one planetary wave and all its secondary wave from interaction with tides will located at the same column, and we call the peaks at the same column as one family. For each family, we calculate the product of all their members, and the family associated with the maximum and the second maximum of this product are here colored in red and blue. And the zonal wave number estimation of these members are exciting. The wave number suggests that in the red family, this one is a Rossby gravity Morse, and all the others are the secondary waves of the nonlinear interaction between this wave and the tides. And for the blue family, this one is a Rossby gravity Morse, and all the others can be explained as the secondary wave, except this one, where the wave number does not satisfy this explanation. We also looked at the seasonal variation of this quasi-2D Rossby gravity waves and their secondary waves through composite cross-wavelet analysis. So the main takeoff here are the dominant zonal wave number is different between summer and winter, and the seasonal variation of the quasi-2D wave they are different from the seasonal variation of their secondary waves. So these waves maximized during summer and the secondary waves maximized during winter. Using similar methods and similar radar configurations, we have identified the zonal wave numbers for a variety of waves, as sketched here in this frequency and zonal wave number plane. And in this plot, the open small circles denote tides, the solid points denote planetary waves, and the open triangles denote secondary wave from the wave-wave interactions. Among them, the blue upward triangle denotes the upside bands, whereas the downwards and red triangle denotes the low side bands. In this plot, two regions was zoomed into individual plot here, and we have just discussed the secondary waves included in these green circles. For the rest, I refer you to the papers list in this box. And we can color these waves according to their association with SSW. So we find that high order tidal harmonics, some planetary wave, and the interaction between planetary waves, and also the sidebands nearby 12 hour, as well as the lunar tide, they are associated with the SSW. Here's one sentence summary. So the planetary wave and tides nonlinear interaction increased the variety of MMT waves significantly. Thank you very much for your attention.